slider will be located at the particular point of time. It is just below that video that is coming on your screen. This is the particular arc that has been cut from A, and it has been labeled as C. Moving on. Now next I'll connect my BC. I'll beg your pardon that these labels, A has to be replaced by O, B has to be replaced by A, and C has to be replaced by B. So kindly pardon me for that I have used different notations for that. Now we'll connect the connecting rod. We'll refer to this as a crank and we'll refer to this as the rod, and we'll solve the problem further. So AB is done, that is a crank. Now I've drawn the connecting rod, so I know my slider will be here. So what is my next step? Draw a slider. A slider is a rectangular block as we saw in the figure. So I'll draw my imaginary slider of any dimension because my slider dimension is not mentioned to me, and basically we just want the position of the slider, the midpoint of the slider, that is point C. So drawing a slider is just to make you understand that this is a slider and crank mechanism, and it does not have to do a lot with the question because we are just considering the center of the slider, and the point C is what we want to have. The next point. Now with radius equal to BP, now we have the crank and mechanism is ready. Now what we want to do is we want to plot that point P for which we have to draw the locus. So for that we will have to do what? It is at a distance of 300 mm. So we will plot BP. This is the locus and this is the distance. So for this particular point P, we have to draw the locus. Now how will we draw it? This is one single position at say time particular time T. So what are we going to do next? We are going to plot different positions of the crank. Along with that, for that particular position of crank, we are going to draw particular position of the connecting rod. Then we are going to draw the particular position of the slider. So once we have all these three things, we can take the distance and we can plot the locus. It is as simple as it sounds. Now we move to draw the locus of point P. What do we have to do? The first step is dividing the crank circle into 12 parts. See, this step has to be understood very carefully because in all the problems that we are going to encounter in the coming problems, we are going to use this particular concept. We are going to divide the circle, or we are going to divide the crank circle into 12 parts. So what is the basic procedure of doing that? See, if we have taken any random AB, we don't know at what angle it is. So how should we draw the angle and we should divide it into 12 parts? So for that, first of all, we know we have to divide it into 12 parts. So we know 12 parts. So the circle is made up of 360 degrees. It's just like we have a pizza. So now the pizza has to be divided into 12 parts. So how are you going to divide it into 12 parts? What I'll do is I'll divide my 360 degrees by 12. Now that 360 by 12 gives me 30 degrees. So I'll draw a single line, and from that I'll keep on taking 30 degrees, 30 degrees, 30 degrees, 30 degrees, 30 degrees 12 times. So once I am done with that, I'll reach to my original position again. So my circle, or my say pizza, is divided into 12 parts. Now let's see. Now we use a protector. So now keep the center of the protector at A and base at AB, and mark 30 degrees at B1 and join AB, and this is the 30 degrees. Angle BAB1 is 30 degrees. Now we need not go on measuring 30 degrees and marking it on the circle. The easiest way is to put my pointed end at B. Put my pointed end of the compass, vartul, at B. Measure the distance of B1 and then start cutting successive arcs on the circle like this. We have just taken the length B1, kept the pointed end at B1, cut an arc at B2. Keep the pointed end at B2, cut an arc on B3. Put a pointed end on B4, cut an arc on B5, B6, B7, B8, B9, B10 and B11, and again we come to B. if your final measurement B11 and B is not coming proper, then you have not taken proper precautions in marking the arcs, or there is some distance that you have left between some arc. So the best thing to do is rub off the old drawing and start again. Don't ever rub one arc and do it again. The basic thing that you should keep in mind, if you have committed a mistake, start doing it from the start. If you keep on following this procedure in problems, or in doing any other work, or in solving any other problem, you will be able to know, okay, what faults you have done. So encountering that faults, overcoming those faults will you will be able to avoid these particular faults in the future. So it is advisable, so if you miss this particular point B, then you rub off the figure or take a new page and draw it again, because it's just practicing. The main motive is that it should not be wrong in the exam, or it should be not wrong when you are going in an industry and applying it for designing a particular mechanism. Now the next step. Now, as I mentioned, I would like to go back to the previous slide. We discussed what is the importance of plotting, we knowing the crank is going to rotate clockwise or anti-clockwise. As you can see in this figure, I have started marking the arcs from B to B1, B1 to B2, B2 to B3 in clockwise direction. Because in the question it says it is clockwise, that's why I am going clockwise. If my question says anti-clockwise, then I'll go the other way around. Then my B1 will be at B11, my B2 will be at B10, B3 will be at B9, B4 will be at B8, and vice versa. Everything will be changed. So all the positions that I'm going to plot, all the labeling that I'm going to do is changed. That's why it is very important that you should keep in mind the question says clockwise or the question says anti-clockwise. Now I have hidden the slider. As you can see, it is written in the yellow box that I have hidden the slider so that there is more clarity. So it is not that after this particular step you should rub off the slider. It's just that I have hidden the slider so that you can understand that this is what is happening and where the arcs are being cut. Now, how are we going to plot the connecting rod with respect to different points of the crank? We are going to just follow the procedure that we did after making the crank AB. What we did after making the crank AB? After making the crank AB, I took distance equal to the length of my the connecting rod. I put my pointed end at B and cut an arc at C. Now what I'm going to do? I'm going to do the same thing. I'm going to keep my radius, that is equal to my connecting rod, that is 750 mm. Keep my pointed end at B1 and mark an arc at C1. And then connect B1 to C1. Now B1 C1 is my connecting rod, which is at 30 degrees. I have already started, the mechanism has already started working. It started from B, now it has gone to B1, so my slider has reached C1. So along with that, I need to know where did my point P go. So for doing that, what should I do? Again, the same thing that I did after drawing my connecting rod. What I did take 300 mm. That was the distance of the point given from a particular point in the question. So I took BP, that is 300 mm. Now I'll do the same thing. I'll take 300 mm radius, keep it on B1 and cut an arc on the connecting rod B1 C1 like this. This is P1 and mark it P1. So now for this first point I have already had. Now I have the second point, that is P1. Now what will I do? Now my next step is that I'm going to follow this particular procedure again and again for B2, B3, B4, B5, B6 right up till B11. So let's see. For B2, now we are going for B3. The same procedure has to be followed. First the connecting rod has to be made. First the arc has to be cut on the particular line. Then the connecting rod has to be made. Then we mark point P4. Going along P5. We have P6, P7, P8, P9, P10, P11. So for all my particular positions of the crank, I have drawn my positions of my connecting rod, my slider, and I have plotted that particular point P on each and every connecting rod that the position has come. So now what is the next point? Now I want my locus. So we have now drawn all the points. So now what should we do to plot the locus? Very simple. Start from point P. Now you must remember when you are in childhood, in magazines or in newspapers, there are figures and there are different dots and they are numbered, and you say you connect those particular dots, so you will have a figure and then you will color the figure. So it was very fun. So that same thing we have to do. Those people taught you how to make locus. See how creative. So now again we'll see from point P to P11, I'll make a smooth curve that passes through P, P1, P2, P3, P4 right up till P11, which looks something like this. This particular ellipse, it forms something like an ellipse. It might not be a perfect ellipse, but we are going to call an ellipse so that you can remember that, yeah, okay, this is a particular curve that I'm going to draw. As you can see, the curves should be smooth and they should not have edges. You should keep in mind that this is a smooth mechanism. It does not have any flaws. It is a perfect circular mechanism. So it is having the same position again and again after a particular interval of time. So it will be a smooth curve rather than having edges at each and every point that you connect. So it is very important that you draw a smooth curve, because there is one thing in EG, in engineering graphics, when anybody is checking a paper, the first thing that they check to look at the figure is right or no. That it can be made out by looking at the figure or say the shape of the ellipse. Say if the shape of the ellipse is not correct, we know that the person has already made a mistake. So it is very important to have the end locus correct. This is what I want to say. So this is the required locus of a simple slider crank mechanism, where there is a point which is there on the connecting rod and we have to draw the locus of that particular point. Now let's move on. Now we have discussed simple slider crank mechanism. The next thing that we were going to discuss, before that, an application. We all know what is this. This is a simple internal combustion engine. Now as I said that this particular mechanism can be used for converting reciprocating motion or oscillating motion into rotatory motion, or the other way around. This is an example where the crank is being driven by the fuel combustion in the engine. The slider is being driven up and down because of the fuel combustion, and the crank wheel, this is the crank wheel, this is a cylinder, this is a piston which can be considered a slider, this is the connecting rod, and as you can see, this is the crank wheel. Now this is combustion, so it pushes the connecting rod, the slider down, it pushes the connecting rod down, and it makes the crank rotate. And this is how we get the output from the combustion of fuel in an IC engine. So this is a particular application of simple slider crank mechanism. Another point that is there, this point and this point, they both are on a single line, which is a mark that it is a simple slider crank mechanism. Okay, let's move on. Offset. Now what we say that it is a slider and crank mechanism, that is also a slider and crank mechanism, so there has to be some basic difference between both of them. So now the basic difference is that the crank has a particular center on this reference line. The line on which the slider rotates is, say, a particular x distance offset or away from that particular line on which the crank is rotating. So this is known as offset slider crank mechanism. Again, to make you understand, I have a line diagram which is animated. Now you can see the difference between a simple slider crank mechanism and an offset slider crank mechanism. Here the crank is rotating here on this particular line, the connecting rod is there, but the only difference is that the slider is not rotating on this line, but it is rotating on a particular distance away from that particular line in the horizontal manner as it did before. Just the difference is that it is away from that line. Okay, so First, again we are going to follow the same thing. The same procedure is going to be followed. What? We are going to draw the offset slider crank mechanism. After that, we will plot the point of the locus what is required, and then move on and plot the whole locus. Okay. Offset OSC means offset slider crank mechanism. I was a bit lazy to write that, so I invented a new short form, that is OSC. Again we are going to read the question very carefully, and we are going to understand the question before proceeding towards solving any problem. In an offset slider crank mechanism, the first line says it is offset, so the picture has to be very clear that my crank, the position of my crank and the position of my slider will be away from each other. Okay, so it is clear that I need two lines. On one line my slider will be oscillating, and on the other line my particular point will be there around which the crank will be rotating. Okay, now let's see the next point. The slider and B moves in guides along line CD. Now it is clear that the line that it's mentioned is CD, and it is away from the particular point or particular line on which the crank is there. 300 mm below the axis O of the crankshaft. This makes the picture very clear. There is a line which is CD on which the slider is reciprocating. Now there 300 mm above that is the line on which the crank is there, on which the point O is there. Or we can say the other way around, that there is a line on which the crank is rotating, and 300 mm below that line we have the particular line on which the slider is reciprocating. Okay, now let's see. He has given me the specifics of the mechanism. Now what does he want me to do? Why he has given me this mechanism? He wants me, or this question wants me to plot locus of point P, which is 450 mm from A along AB. Again, it is similar to the problem that was there back. We are going to do the same procedure. There is only one minute difference that is going to be there. So again, we know that this 450 mm is away from that point A, and AB is the connecting rod. So my point, the locus, will be on the connecting rod. So what do I need to do? Again, I need to have the crank positions, I need to have the connecting rod positions, I need to have the slider positions. Now if I have all these particular things, I will have the locus of point P, which is required.